Welcome to Pomodoro Joe for Thursday, February 9th, 2023. Today we're doing LeetCode problem 2306, naming a company. This is a hard problem. And the problem statement says, you are given an array of strings, ideas, that represents a list of names to be used in the process of naming a company. The process of naming the company is as follows. Choose two distinct names from ideas. Call them ideas A and B. Swap the first letter of ideas A and ideas B with each other. If both of the new names are not found in the original ideas, then the name idea A space idea B is a valid company name. Otherwise, it is not a valid name. Return the number of distinct valid names for the company. Okay, so we don't need to actually return the valid names themselves, we just need to return the number of valid names. All right, this is a hard problem. And with that, we will put 25 minutes on the Pomodoro and get started. As with most problems, I like to have my result at the beginning, so 0, and we will return result at the end. So for this problem, I think I will approach this using specific data structures. We just need to pull the first character off of each idea and swap it with the other. So one thing we can do here is just pull out those first characters and keep a dictionary of the first characters to some list or a set of the remainder of that idea. By breaking that down into a dictionary to have the set of letters and the, I guess I'll call it the head and the body of the idea. So the head being the first letter. When we separate that from the rest of the idea, then we can look for matching ideas with different heads. I guess, for example, let's see if I can give a good example here. Yeah, so coffee and toffee. These have different heads or different start characters, T and C, but they have the same body, O-F-F-E-E. Now, if we tried to swap those two, swap the C and the T, we'd end up with coffee and toffee and toffee and coffee, which would not be a valid company name. So first thing I'll do is we'll actually break these down into the letters, the start letters of every idea, and the rest of the idea. So I'll call that a, I don't know, letter to idea map. And we'll make that a default dictionary. And it could be a list, but I'm going to make it a set. I think that'll be easier. Okay, I think I'll also want to keep track of all of the unique letters. We could use the idea map keys itself, but it might make it easier just to have a separate list of letters. And that will also be a set. Okay, now that we have our two data structures for holding this data, let's actually populate them with the ideas. Okay, so here I'll need to pull the idea, the first letter off the idea. So I could do like idea at 0. I think I'll make it easier on myself and actually have the letter. And now this is a set, so we will add, I could add the entire word, but I really only need the body of the word, everything but the first letter. So I'll say from idea of 1 to the end. And then in my letters set, I'll just add the letter. Okay, so this gives me a dictionary that maps the first letter to the rest of the word, and I have a separate set that just gives me all the unique letters. Now, the idea that I'm going with here is that if I'm going to swap two first characters, that means that they cannot have matching bodies. For example, with the coffee and the toffee, I can't swap the two characters because the rest of the words match, or the rest of the idea matches, the O-F-F-E-E. So as long as I don't have a match there though, if these are different bodies on the idea, then we can swap those first characters and we're okay. So I'll say, let's see, for every letter in letters, oh, this is going to be tricky. I think I need to go through, yeah, this is a little bit trickier than I thought. So what I need to do is turn that set of letters into a list. So I can essentially say, let's start at the first letter, and then for all the other letters, let's look for bodies that don't match the words that are matched in this first letter. I'm not describing this very well. Let me try this again. So I think what I need to do is create a list of my letters so that I can iterate through every letter and all the other letters. So essentially choose a start letter and then go through all the other letters. Then move on to the next start letter and go through all the other letters. So I will turn my letters into a list. Python's great. I can just pass it into list. So now I have a list of letters. And I will probably need to go through the length. So I'm going to get that length. I'll call it letters count. Okay. Now comes the heart of the problem. Now I'm going to choose a letter to start with, take all the words that are mapped to that letter, so essentially all the bodies of that letter. Then I'll go through all of the other letters looking for bodies that don't match anything that's in this letter's set of bodies. If I find something that doesn't match, then I can swap those heads and I have a new pair of idea names or a new pair of company names. And the other thing to note with that is if you have one company name like Coffee Donuts, then you can flip those over and make it Donuts Coffee, and it's a unique company name. So for every pair of unique unique ideas, I actually get 2 unique names. Okay, so let's do this. Okay, so we'll have for I in range letters count, and then for J in range, we'll actually go from I plus 1, so we will skip this letter and go to the next letter. But we still need to go to the end of our list of letters. Okay, and now let's see, I need to actually pull the letter out, so I'll call this I letter. And that's going to be letters list at I. Okay, so I have my starting letter, my I letter, and I'll have my J letter here. So now I need to go through and look for these mismatched bodies between all of the bodies in the ith letter set of ideas and the J letter set of ideas. Let's see, how am I going to do this? Well, first let's just get all of the letters, or all of the I ideas, I guess. Okay, so we can turn the ith letter into a set of our mapped ideas by just getting it out of the letter to idea map and passing in the ith letter. We can do the same with J. So J ideas equals okay, so now we have our 2 sets of ideas. And again, this is where Python is awesome. So these are sets. What you can do with sets is you can find unions, you can find intersections, and in our case, we actually want to find the differences. So we want to find all of those, I guess, bodies or all of the ideas in I that don't exist in J, and vice versa. So let's see, how do we do that? That's actually super easy. So I will call this like unique I, or I unique. There we go. So all the unique elements that are in the I set, but not in the J set, you can just say I ideas minus J ideas. This is a set operation, and it's getting the difference between these two sets. Now I want to do the same for the j. But I have to do j first. Okay, so now I have unique elements that are in I and all the unique elements that are in j. Now I know that I can swap those elements without any problem because they won't have any conflict in terms of swapping the first characters of these elements won't result in a matching, or won't result in an idea that's already in our list. Okay, so now that I have these set of unique elements from I and unique elements in j, I can do these combinations and our result will be, and this is where it gets a little bit tricky, but for every unique I element, so we'll get the length of I unique, we can pair it with a unique element in j, so we can multiply the lengths together. This is like a permutation. So for every element in I that's unique, we can add it to every element of the unique element in j, and then we can multiply that whole thing by 2 because we can just swap that company name. We can swap the order of those and we get 2 unique company names. Okay, I think that will do it. Let's see what happens. Okay, and we are definitely missing something. All right, thought I'd jump in with a little voiceover here. We'll speed through this. At this point, I was confused about what was going on. It seemed like my algorithm should have worked, so I poured through the code, looking over every line, trying to figure out where I was going wrong, what was in each of my sets, what was in my dictionary. I started doing some printouts just to see if I was missing something. Everything seemed to look good. I couldn't quite figure out what was going wrong. I was getting super anxious, and then I discovered it. 2 times 1 is 2, but we multiply that by 2, so we get 4. Oh, you've got to be kidding me. Oh, it's plus equals on the result. Let's try that whole thing again. Let's submit that and see how we do. Okay, and we pass. All right. We do okay. 72% for runtime, 11% for memory. Not too shabby. I am way over time. There are definitely things that we can do to improve this. For one, we can pull this ideas out and put it up here. In fact, let's just do that right now. Okay, we might go over time. I'm okay with that. Then we still have to do these down here, do our result. And what else could we do? There's probably a couple other things we can do, but let's just see if that saves us anything. Not really. 70%, 10% compared to 72 and 11. Okay. Anyway, I am out of time. Our Pomodoro is almost up. So we were able to get it done just barely, mostly because of my silly oversight on doing a plus equals on the result. So hope you learned something. This one's a fun one. It is tricky for sure. That's why it's a hard problem. But if you use these data structures, you can do a lot with, and that's it. We're done. All right, we are out of time. Hope you learned something. Hope you had fun. Hope you can go out and try this one on your own. It's definitely a fun problem. That's it for me. Please write better code than I do, for sure.